Okay, this is Homework U12 Question 1 on vectors, and the first question tells us that we've got a particle P of weight 6 newtons, so there's basically a force acting vertically downwards at this point, attached to one end of a light inextensible string. There's a string. The other end of the string is attached to a fixed point O, which is this thing over here, and a horizontal force of magnitude F newtons is applied to P. And the question is asking us to find the tension in the string. That's this tension going up this way, and the value of F, which is this horizontal force along here. So two things we're after, which means we're probably going to be looking for two separate equations. Okay, so let's get stuck into this one, and first thing we're going to think about is annotating the diagram a little bit so we can see the forces. And there's going to be a tension on the string going this way, so there's T for the tension, and this force here we're going to separate into two forces, one horizontal, so we're going to imagine the force going this way, which is going to be T horizontal, and effectively there's a force going to be going up this way, which is going to be T vertical. And we're going to resolve both of these two forces in terms of this force, given the fact that we know that this angle up here is 30. So this is opposite the 30, so it's sine, and the sine of 30 is equal to the opposite, TH divided by T. So that means that the TH here is equal to sine of 30 times T, and the sine of 30 is a half, so this is just equal to 0.5 times T. Okay, likewise this force here is adjacent to the 30, so this is going to be resolved with cosine. So the cosine of 30 is the adjacent divided by the hypotenuse, so we rearrange that equation to say that TV is T times the cosine of 30, which is T times root 3 divided by 2. Okay, so there's all our forces. So we've got a horizontal force that way, another horizontal force going this way, which is this 0.5 T. Vertical forces are this one going up here and this one coming down here. Okay, so let's resolve the forces, and we're going to resolve the forces first in the y direction. So we'll state here what we're doing. The sum of the forces in the y direction are equal to 0, and we'll make all the forces going up the way being positive. So that means that we've got the TV, which is going up the way. I'll just put the TV in first, and the 6 newtons, which is going down the way, which is now negative, so that the vertical component of the tension minus 6 is equal to 0, and this TV is equal to the T times root 3 divided by 2. So we've now got root 3 times T divided by 2 minus 6 is equal to 0. We take the 6 across, so we get T is equal to 6. We multiply through by the 2, we divide through by the root 3, and that gives us a tension of 6.93 newtons. Okay, the next part of the question was to find the force F, this horizontal force. Now again, we just do exactly the same thing. We now sum the forces in the x direction. Sum the forces in the x direction are equal to 0, and make everything going from left to right being positive. And so basically what we now have is this force F, which is positive, and anything going from now right to left is now going to be negative, which is this force over here. So again, just stating clearly what we're doing. So we've now got F minus the horizontal tension is equal to 0, and this horizontal tension over here is 0.5 times T. So that implies now that F minus 0.5 times T is equal to 0, which means F is equal to 0.5 times T, which is equal to 0.5 times the 6.93 that we've calculated in the first part of the question, and that gets us 3.3 0.46 newtons. So that is part B of the question, and this is part A of the question. Okay, so simply resolving the forces into the horizontal and vertical components, then equating using equilibrium and making sure that we're consistent with the signs and directions. Okay.